blockchain is one of the most important, technological advancement that has happened in the history of internet. I mean, from 2000 to 2018, the internet has disrupted everything. And from 2018 to 2025, blockchain is going to disrupt everything that is on the internet. The biggest benefit of blockchain is that it is not a platform. It is a technology which is sitting on the internet. It's decentralized. That is, no one centrally controls an ecosystem when it's on blockchain. And take the example of Bitcoin. As I said, there are millions of nodes which are available in the world which are running the Bitcoin ecosystem. And those who are unable to understand nodes, I'll give you a very simple example. How many of you used torrent before? Ever in your life you download any kind of files or anything, or ever even heard about torrent? Now, what happens in torrent? Torrent is a peer-to-peer network system in which allows you to download files from different participants. Now, in the torrent, what happens? It's a peer-to-peer distributed network. Now, let's say if I am a user and there are 5 more users in the ecosystem, and let me explain you maybe with the help of paint. Let's say there are 5 participants in an ecosystem of torrent, okay, and this is me. Now, this is me. Now I want to download a file which is actually available with all these 3 people, and they're actually connected in a network. The moment I will send a download request, which is again a transactional request, I will start getting the files for all these 3 users. Now that's a distributed network. That is one of the biggest part of blockchain when we talk about distributed ledger ecosystem. That's what distributed is all about. And when you see this kind of infrastructure, what happens that one of the biggest challenges in a distributed ecosystem was that all the transactions that I am doing, they are not safe and secure. That means the file that I am actually downloading from these people, I am not really sure what is coming to my computer. That there's no way for me to verify what kind of authentication I would need in order to verify a file. And that's what the biggest challenge. So what blockchain did, blockchain said, fine, let's go to the example of Bitcoin. Right now, in order for me to send money from A to B, which I do in this way, straight away, we think this is straight away, but that's not, because the moment you have a money transferred, you have certain intermediaries who are involved in between in order to get the authentication, the verification, or the auditing gets done. So let's say I send money from my bank account to a different bank account. The first thing, there will be auditor, there will be verifier, and regulator. All these 3 people combine together in order to give their result, unless my transaction is verified and the funds are being transferred. So if I'm sending, let's say, $10, the other party will always receive, let's say, for example, $9.8, because 20 cents has actually gone into the fees. And you might have seen that the moment you send money from a bank account every time, you will see there's a deduction because there's always a service fee which the bank charges. And this is what the bank charges, because they have so many people in between, the middlemen, who are actually not required. Because if I have to send my money from A to B, I just need A and B, no one else. Then why do I need these people? Now, how blockchain helps into play? Why Bitcoin even came into existence? This was the problem which the Bitcoin, I would say, team, the Satoshi Nakamoto team, actually solved. So, have a quick understanding how this works. Now, the moment something happens in a Bitcoin ecosystem, what happens is that there is no central authority, there is no centralized infrastructure. So what happens? This transaction, instead of going directly to B, there are multiple nodes that we have established in the ecosystem, like this. So many millions of nodes across the globe. That means there is no centralized ecosystem. And the first part of a transaction when it goes into a blockchain ecosystem is the distribution. The moment I am going to send my transaction from A to B, my transactions are, in a Bitcoin or ecosystem, they are divided in a form of public key and private key. We'll not get into that detail right away. Once you join the course, we'll go that. But a public key, you can say, is your account address or your Bitcoin address, and a private key is a key which you will use in order to access the funds which are in your addresses. So every account in the Bitcoin ecosystem has a public key and a private key, whether it's a sender or a receiver. Now, the moment someone sends a transaction or initiates a transaction, instead of going directly to B in this case, what happens? This transaction, since all the nodes are connected with one another, because it's a peer-to-peer system, all the nodes are connected to one another, you see, in this way. The transaction will start getting distributed to to their nearest node. So this might go to this one and this one. Again, this will go to this node, this node, this node, so on and so forth, unless the transactions are distributed across the network. Now, what happens? The transactions is executed. The biggest problem that the Satoshi Nakamoto fixes that I will not need a middleman to do that job for me. In that case, we started, in order for me to verify a transaction, I need to know what is authenticity. And that authenticity comes from the miners, the people, the nodes that we have in between. These nodes actually mine the transaction. Now, mining is, you can simply say, is the verification of a transaction. So let's say if A is sending 5 bitcoins, in this case, to B, now whether A actually had those 5 bitcoins or not is what is being tested, and B, when it's being sent to B, it does B actually exist or not. Now, these are the basic verification when a miner does that, and these are all mathematical computational tasks. There's no human task involved, so there's no human involved in any of the Bitcoin transactions. So when a person initiates a transaction, it goes back to the ecosystem. The miners, what they do now, obviously in a Bitcoin ecosystem, there are millions of transactions which goes every second. There are millions of transactions which goes every minute in order to facilitate. So if there are, let's say, 10 users, they might be sending transactions to and forth to one another every time. So what happens? A miner, in the whole ecosystem, you will see many transactions which are there in the network. So a miner starts grabbing the transactions in one by one, and what does it? Grabs the transactions in one block. It puts the transaction, and these are unverified transactions. There's no verification happen. So the first part of a transaction is that a transaction gets initiated, then it goes to gets distributed among all the participants. Then the miner grabs a number of transactions and they start mining it and verifying every transaction, start checking the authenticity of a transaction in terms of the validation. Now, once that happens, let's say there are multiple miners who are mining the same set of transactions. There will be one miner only who will be able to submit the solution, and the person who, or a miner who submits the solution, is the one who actually claims the block. Now, the moment a miner submits a solution that, hey guys, in the blockchain that I have mined a block, these are the set of transactions which I say that are correct, the rest of the people who are mining at the same time will have to come on a consensus. That means they have to come on the same decision that yes, whatever this other miner has submitted, that the transactions are verified or validated, I am on a consensus with them. And once the miners come in a consensus, that's where the transaction gets completed, because that's when the block gets submitted to the blockchain. Now, this is a basic transaction life cycle of what happens in a Bitcoin transaction. And when this part happens, that's where the B gets its Bitcoin and the transaction is completed. Now, this is just a creation of block. Now, when I say it's a creation of block, what do you think the word chain means? Now, we have a word block. I have given an answer for that. What do you think the word chain will refer in there? Blockchain, because that's how the whole technology is evolving. What do you think the word chain will refer when I already have a block now? All right, yeah, so all the blocks are connected, but the question is that how are they connected? So let's have an understanding about that. Let's say now when a block gets formed, this is how it looks like. Now, have a look at this. Now, every block in a blockchain ecosystem is actually connected to one another. That means if I have, let's say we have block 1574, 1575, uh-oh, and 1576, you see that all the blocks are connected to their previous block. And that's how the chain gets connected. That means the blockchain is about the connections of all the block. Every block will have different number of transactions. So that's exactly how the blockchain words came from. And I'll tell you a very funny story. The word blockchain never actually existed before the time this Satoshi Nakamoto submitted the paper or published a paper of peer-to-peer exchange in which he explained the block and the chain, and he combined the word blockchain, hence coming and talking about the word blockchain. So that's exactly how the Bitcoin blockchain works like, and I'll tell you that's exactly how the blockchain ecosystem looks like. Now, one thing I would like to tell you that, as I said, blockchain owes its name to the way it stores transactions data in the block, which are linked together, to form a chain, like I showed in the figure. Now, as the number of transactions grows, so does the blockchain. So people ask that are there scalability issues in the blockchain? I will say no. I mean, think about an example. if we have an infrastructure in a company, every time the data gets increased, the companies put more and more infrastructure. Same thing goes with blockchain, that we will need more and more nodes every day as the number of transactions grows. So all the blocks that record and confirm the time and the sequence of the transaction, which are they're logged into blockchain with a discrete network, which is governed by the rule that we set by the Bitcoin blockchain in this case. So if you see this diagram again, go that it has a hash. That means every block contains a hash. Now, I will not again get into much of hash, but I would say hash you can say is a digital fingerprint or a unique identifier of a block. Okay, and so that each block contains a hash, timestamp batches of what are the recent valid transactions there, the hash of the previous block in order to connect to the block. So all the previous block hash, they links the blocks together. And what happens once a link, they prevents any block from being altered or a block being inserted between two existing blocks. Now, you all must have heard about that in a blockchain ecosystem, a transaction can never be manipulated. Have you all heard about that ever before? That yes, in a Bitcoin blockchain or any blockchain, a transaction can never be altered. It can never be changed. So once something is there, it's there. And that's one of the biggest security feature that blockchain brings to us. So have you all heard about this kind of system that existed with blockchain? So now we have understood that what blockchain is about, why the blocks are not altered. What is that one thing which keeps the block unaltered and I cannot actually penetrate a transaction or change a transaction? Why does this happen? I've told you how blocks looks like, what a block consists of, what is a blockchain at the end of the day. But as I said, that what is it one part that actually avoids from the blocks from being altered, or say a change a transaction. The previous block, if you see this example, the one that you have, that every block has a previous block hash, and that hash is linking the blocks together. So what happens, these hash prevents any block from being altered, or say a block being inserted between two existing blocks. In this way, what happens, all the subsequent blocks, which are like one by one, they strengthens the verification of the previous blocks, and hence the entire blockchain, because all the blocks are verified and they're connected to one another step by step by step, and hence what is happening, they're strengthening the security. So in order for me, so let's say take example, if I have to change anything if I go and change anything in block 1576, you will see what happens is that since 1576 consists of the block 15765 hash, and 1575 block consists of a hash of 15754, that means if I make a change in just 1576, the change will actually go and reflect the rest of the blocks. And what happens again in the blockchain? The miners has to agree on a consensus. And the moment you see there's a change in transaction, the miners will never come on a consensus, because that transaction never existed. And hence the blocks will get rejected, the transactions will get rejected, and hence the system becomes immutable. And the method that you can say renders the blockchain tamper evident, lending to the key attribute of what we call as immutability, that blockchain is immutable. So one thing I'll tell you, to be clear, while the blockchain contains the transactions data, okay, that all the blocks have the transactions and the data, it's not a replacement for databases or messaging technology or transactions processing or business process. The blockchain contains the verified proof of transaction, which is the biggest problem that we face. There's no trust. That means the blockchain essentially, you can say, serves as a database for recording a transaction, and the benefits are beyond those for a traditional database. So is blockchain a replacement for database? No. But is blockchain a secure database? Yes. It serves as a database for recording transaction, and it's far more, you can say, a better way of that. So that's pretty much about blockchain. That's all about. Now, again, as I said, Bitcoin is one of the first cryptocurrencies which got involved in 2009, and that's where the blockchain ecosystem came into existence. Now, Bitcoin is the first cryptocurrencies. We all know about that. It used a mathematical cryptographic algorithm. Because they are called cryptocurrencies, we should understand that there is cryptography involved in their every transaction. And at any given point of time, there can only be 21 million Bitcoin that can ever be created, that means ever be mined. All right, so let me give you a quick example with the same one. have a look at this picture, that all the blocks that I have, 7.4, 7.5, and 7.6, they all are interlinked. That means if you see the purple arrow which is going from 7.6 to 7.5 and the green arrow going from 7.5 to 7.6, they start connecting these blocks. So when 1576 was created, it had a hash of 1575 and 1575 had a hash of 1574. The moment I try and change anything in block 1575 or try as 1576 and try and alter a transaction, because the previous block hash value was fixed, it will get changed too, because anytime you make a single change in a transaction data, the hash value gets changed. And the moment the hash value gets changed, what happens is that all the blocks which are linked together, their values get changed, and hence we cannot modify a transaction, because once all the blocks have a changed value, the blockchain will not accept that. And I'll show you a quick example for that. So this is how a hash looks like. Now in the Bitcoin blockchain, we use a SHA-256 hashing algorithm, that you can say in a layman language, an encryption algorithm. Now see, I do not have a data right now in this place, and I have a hash text where the moment, let's say I try something, my name is Vishal, you see on the bottom the hash gets changed. And that's what happens. Now in this case, whatever transactions were there with block 1575 and 1574, that was fixed. And the moment in 1576, since they all are interlinked to one another, I try and make a change. Now, in this case, let's say that any transaction was, let's say, for example, my name is Vishal. And the moment I even try and change one single thing in this, let's say, okay, I will say my name is Vishal Nigam, you say the hash has again changed. That means even a single space, even a single alteration in a transaction will entirely change the hash value. That means when a hash value gets changed, everything in the blocks will get changed. And so I was telling you about the Bitcoin, that there can only be 21 million Bitcoin on any given day, and they all are on a distributed ledger. Again, quickly showing you a distributed ledger. Go on this website, blockchain.info.charts, and you click on this blocks, you will see that I have different blocks which are there in the blockchain. And this website is just, you can say, is a block explorer which helps you to see what other transactions I have. And as I said, that every block consists of a number of transactions. So if you see, this block 984 has 163 transactions, block 983 has 2375 transactions, and this is the time that this block took to get mined. Now again, why these blocks are taking this much of time to get mined, etc., we'll talk later, and how that things work. So the benefit, how these 20 Bitcoins are created, every time a miner mines or verifies a block, they get Bitcoins as a reward, and that's the way how Bitcoins get created. So if someone asks you what are the possible ways of getting Bitcoins, just do. Either someone sends you, or a miner mines a Bitcoin. There is no other way in on earth where you can actually get a Bitcoin for. So that's how the Bitcoin's creation takes place. So that's pretty much about the Bitcoin and blockchain technology. Now, what are the features of blockchain? As I've discussed, hash encryption, distributed public ledger, proof of work is one thing I must say. So all these miners, they actually, put in some kind of computing power capacity, okay, in order to mine the verification. It's more of like, putting the computing capacity. That means they're actually providing some amount of work to prove that whatever transactions or whatever block they are submitting is right. That means they're giving us a proof of work in order to mine a block. That means that's what exactly the proof of work mechanism, or you can say a mining algorithm, that is required in Bitcoin blockchain. And there are so many consensus algorithms which are available in the Bitcoin ecosystem or a blockchain ecosystem, which are being used every day in and out. So anyone can be a miner. If you have the enough hardware capacity with you, you can be a miner. That means anywhere in the world can someone be a miner, okay? You just need to have that amount of hardware which is able to mine the blocks, and that's how the mining works. Now, the government is going to use blockchain a lot. I mean, I'll tell you, in India, the Andhra Pradesh government is building the land registries on blockchain, and I am designing the whole ecosystem for that. So if you go on Google and search about the land registry with Andhra Pradesh government, you will see that there is a system which is being built upon in order to get that whole ecosystem done. And I'm building that whole ecosystem on Hyperledger, which is one of the frameworks of blockchain, and Ethereum in order to build that whole ecosystem. So that's how things are working in India. And there's so many other applications on KYCs for banks, the identity verification. I'm not really sure if you know that there's a Aadhaar chain. We all use Aadhaar card in India. Aadhaar chain is coming very soon to protect the privacy of users. So many applications are being even taken by the governments. On the private side, every enterprise, every bank, every startup, every company is trying to do something or other with the blockchain. But the biggest problem with this is that there are no, I would say there's very less amount of skill set which is available in the market, and that's one of the reasons that I have started personally training with different companies in order to get this thing done. Because for me, being a CEO of a company which is running and building blockchain solutions, I am having a hard time finding resources because I don't have people who know with the blockchain development, and that's one of the reasons that we need to build the resource pool by ourselves before the things run out of time. So that's how it is does. One of the best job for a non-tech person, Ram, is a blockchain analyst, the person who actually understands how these things actually operate. So that analyst is a person who actually analyze the whole ecosystem and then give their suggestions. That's the best part job of analyst. That's how it works. The node synchronization is one part. As I said, it's a distributed ledger ecosystem. Every node is distributed. They're connected in the same, they're using the same protocol to connect. It's more of like a torrent ecosystem, right? The moment you download BitTorrent, it gets connected to every torrent machine that's available on the planet. Same the way it works. Storage, every machine that's connected to the blockchain has to have amount of storage which is capable of downloading the Bitcoin or blockchain. For example, if you want to become a Bitcoin node, you need to have at least 150 gigabyte of space or storage space in order to do that. And I would say 100 gigabyte more storage in order to make sure that when a blockchain increases, you don't run out of space. Power consumption is one thing which is a worry, because if everything goes the way it is going, by 2020, the amount of power that the whole Bitcoin ecosystem will consume is going to be similar to the amount of power that the world electricity is using. So that's not a worry, but that's okay because that's how the ecosystem will evolve. So that's how things will work. Blockchain is nothing but a database. You are one of the person that who will have the best understanding about how the transactional cycle should work. So if let's say if you design a system for someone and they ask you to design my blockchain ecosystem, and if you know how the ecosystem operates, the basic frameworks operates, you can practically design a system in terms of database. Do we need any language for blockchain? Not exactly, because blockchain, as I said, is not a language, not a platform. It's a technology, and you can build technology on anything, whether you know C, C++, Java, Python, anything for that matter. So let's say, for example, I have 10 nodes connected to my Bitcoin network. I'm the one who are going to manage my nodes. There is no admin. There is no one single authority who controls that. If a person A is passing money to person B, then as distributed ledger, will person see my transaction? Yes. If you are passing, again, go just have a quick look at the example that I just gave you. I have this block, and this block has so many transactions which are there. But in the case of these Bitcoin ecosystem, blockchain ecosystem, every user is pseudonymous. That means no one knows you, that who exactly are the users. One of the biggest benefit of blockchain, guys, is that no one knows the user, that who are my users, who will actually get to see me. But yes, are my transactions visible? Yes. But will anyone know that what is my address? No. The only way the Bitcoin system will shut down, either the internet gets shut down or all the nodes which are available over the planet get shut down. Else everything is available. Okay, so let's quickly talk about the use cases that we have in blockchain, the trends. Okay, now the use cases in the blockchain that we have are the financial services, which is one of the basic disruption that's coming. How the trades can be settled super fast. So it takes me about 12 hours to 2 days, depending upon the aspect that how things happen. Now now think this way, that it takes near about 12 hours to 48 hours for a transaction or a stock to get settled down. That's too much of a time. How much time a crypto trading ecosystem operates? it operates 24/7 because all the transaction settlements are in real time, and hence the trading ecosystem, the trade settlement is one of the biggest application that is going to use blockchain very soon. And those who are in US, I'll tell you, Nasdaq is going to have already built a blockchain ecosystem platform where they'll be shifting the trade stocks very soon, step by step, and that's how they will be able to do that. Now, voting is one of the examples. Think about a scenario where all the people can actually vote, where you have a decentralized infrastructure. And one of the biggest challenges with voting is a fraud. That once a voting happens, there are so many fraud ways you can actually fraud the votes and get the results in your favor. But as I say, everything in the blockchain is transaction. Everything on the internet is transaction. And once a transaction gets executed, we cannot change that. It's immutable. And hence, voting on blockchain becomes the most successful platform. And there's already a plan on that. So there's a website called as Follow My Vote. This is Estonia. Estonia, I'm not sure if you know about this country. Estonia is a country which is already using the blockchain voting for almost 3 years. They're using doing all their elections with the blockchain platform, and that is one of the I would say most successful blockchain platform that we have in the ecosystem. You see, Follow My Vote. So that's one thing you can actually go and have a look at that. What exactly, how the people work, what are the concepts, and etc. etc. Real estate. What is the biggest challenge that you think that the real estate industry has the moment you go and okay, one of the biggest challenges that you might find with the one of the is on real estate. What do you think it's transparency, it's the registration, that I even never know that the property that I'm actually buying is actually the one that I'm buying. There are no counterfeits, there are no disputes. And why that happens? Because there's no documentation. And whatever documentation I have, there's no authenticity. There's no one who can verify that. How blockchain can help that? The moment I start doing a transactions from the start till the end, everything can be on blockchain, because every transaction, once it's on the blockchain, is immutable. And hence, the real estate is one of the problems which is going to be solved with the blockchain. And there are so many platforms, again, which are doing the same job for the same. I consult a lot of companies and I actually tell them and advise them how to, migrate blockchain, try understanding the aspects of different infrastructure they have, their current ecosystem, the database, the servers, and how they can actually move from the current ecosystem to blockchain, and whether blockchain is even required or not. So that's how it makes. If I am sending money from the Bitcoin ecosystem, that's where I am using the system. I'm not depending upon anyone. In the banking system, you have to literally depend upon the bank to do that. In the Bitcoin ecosystem, you don't have to depend upon anyone. Even you are one of the nodes. So you can say everyone is an administrator and no one is the administrator in the Bitcoin blockchain. That's how it works. There's no dependency. The whole benefit and a major goal was to take out the dependency out of the whole system. And at last, we have music streams and supply chain. Music stream is one thing, guys. I'll tell you, we all are very much fond of downloading the pirated movies or pirated music and download about that. But think about the people who actually build them. The people never get the money for the kind of work they've done. That 80 to 70% of these things, they actually get pirated, and hence the blockchain can save that. There can be authentication tokens which can do this job. And one of the platforms again to do this is called as Mycelium. Not sure it's Mycelium or Mycelium. Let's have a quick. Oh no, it's Mycelium. That's a platform for music streaming. And then we have a supply chain ecosystem. That's one thing. The supply chain is really being actively worked by companies like IBM, SAP, and all that. They're really looking on the solution to build a supply chain ecosystem where all the parties are a part of the ecosystem, and we do not need further documentation in order to get that job done. So supply chain is also one of the biggest applications which is being built on the blockchain. So as I said, now, apart from these applications, I can tell you healthcare, one industry where I have my personal focus in drug traceability in clinical trials, keeping the patient data safe, then identity verification, document storage. Yeah, such a Mycelium. Good, great stuff of that. It's Mycelium is the name of platform, guys. That's for music streaming. And so the multiple, so as I said, in blockchain, the industry is not specific. It's something like that. You can actually, create the transaction across the world. Everything can happen in a single click of that, and you don't need to depend on anything else. So, brother, there's no common currency to do cross-border transaction, and how we can implement blockchain in bank. Okay, so let me put it this way: every bank will have their own token system in order to get the job done. If you have heard about Ripple, Ripple is one of the platform which is trying to do the same, is to make an XRP tokens and have the banks to build their own ecosystem. That's how it will work.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.